All right, so dividing the polynomial, setting it up first. Now remember, we need to put placeholders because when we divide, we need a place to put it. We need a place to put our x squareds. We need a place to put our x's. And so when we divide, we follow the pattern: divide, distribute, subtract. Divide, distribute, subtract. So you always divide the leading terms. So x cubed over x, that's x squared. Then you distribute that with what you have here. So x squared times x is x cubed. X squared times 2 is 2x squared. As you can see, that's the reason why we needed that placeholder for the x squareds. Now I have a place to put my x squareds. And the last is subtract, so we switch the signs. We bring everything down, and we start all over again. So divide, so negative 2x squared over x, that's minus 2x. Distribute, negative 2x times x is minus 2x squared. Negative 2x times 2 is minus 4x. And then subtract. And then x goes into 4x 4 times. Distribute. So 4x, 4 times 2 is 8. Subtract, you get 0. So it's going to be remainder 0. So that's going to be my answer. Now on number 3, if you get it out of order, just write it in order. So this will be x plus 1, negative 2x squared minus 4x plus 3. So divide, distribute, subtract. Remember, subtract just means change the signs. Divide, distribute, subtract. So I have a remainder. So the way that we want to write this is going to be negative 2x minus 2 plus 5 over what we divided by. A problem like number 5. So x cubed minus x squared plus 1. And remember, we got to include those placeholders. So minus 5x to the 5th plus 0x to the 4th plus 7x to the 3rd plus 0x squared minus x plus 0. So x to the 3rd into minus x to the 5th is minus x squared. If you need to write it out just to visualize it, you can. Now distribute. So minus x squared and x cubed is minus x to the 5th. Minus x squared and minus x squared is positive x to the 4th. And then minus x squared and 1 gives me minus x squared. Again, another perfect example as to why you need those placeholders. There would have been no spot for me to put that x to the 4th or my x squared. Now, I need to subtract now. So switch the signs. So that's 0, that's minus x to the 4th. That gets brought down. So now we do this again. So x cubed into minus x to the 4th, minus x, distribute. And now subtract, so change the signs. So that's 0, that's 6x cubed plus x squared, and then that's plus 0, then plus 0. So then divide again, x cubed goes into 6x cubed 6 times. If you need to write it out, write it out. So now we need to distribute. That times that is 6x cubed. 6 times minus 6x squared. That times that gives me plus 6. Subtract, so change the signs. So that's going to cancel out. You're going to be left with 7x squared and then minus 6. So that's going to be the remainder. So plus 7x squared minus 6 over what we divided by. All right, so for each graph, describe the end behavior, determine whether it's the graph of an even or odd degree function, and determine the sign of the leading coefficient. So A, the end behavior, as x goes to negative infinity. So as x goes to negative infinity, my y is going down. So y goes to negative infinity. As x goes to positive infinity, my y goes to positive infinity. I know it's going to be an odd degree function because one's going up, one's going down. And the sign of the leading coefficient, because it has a positive trend, I know it's going to be positive. This one is as x goes to negative infinity, y goes to negative infinity. Right? That goes down, and then as x goes to positive infinity, y goes to negative infinity. And then because they're both going down, I know it's even, and because the trend is down, I know it's going to be negative. Describe the end behavior of a 14th degree positive or polynomial with positive leading coefficient. You can draw it if you want, so something like that. 9th degree polynomial with a negative. Okay, so that's, you're going to have a negative trend. So for this one, I don't think that this is anything there. Just space. Okay. So write the equation for each polynomial. Okay, so remember it's y equals a times, and then it crosses here, so x minus 1, 2, 3, 4, so x minus 4, and then x minus 1, x minus negative 4, x minus negative 1, and then it crosses here, so we'll say x minus 2, and then it crosses here, so then x minus 4. Now it bounces here, so that's the only one with my even multiplicity. The rest of them, because it crosses through, we're going to leave them as low or as odd multiplicity in the lowest form, so that's why it's 1. And then pick another point to plug in. That would be this value here, which is 0, 2. And so 0, 2, 2 equals a times 0 plus 4 times 0 plus 1 squared times 0 minus 2 times 0 minus 4. So that's 4 times 1 times negative 2 times negative 4. So that's a times, what is that? 4 times 4 is 16. Times 2 is 32. So divide by that, a equals 1 over 16. So you just need to make sure you plug that in for a. So when we condense any of these values, you bring up, so that's going to be y to the 4th. We condense it into one log, so it's log base 2. If your log is positive, those factors are on top. If your log is negative, those factors are on the bottom. That ends up canceling out, so you get log base 2 of y to the 4th. So expanding, each factor represents a log. So I have 3 logs here. So log x plus log y. plus 2 log z.